Okay, we're going to meet in this room here again tomorrow. So actually, I don't have any computer time scheduled, unfortunately, this week for you, other than you need to find time to that there. I will go ahead and make I'll set the due date for the midterm project or the assignment probably next Thursday after the holiday. Now, next Wednesday's National Day out there. So it's the Malaysian version, and everyone gets mad at me for saying of the 4th of July in the U.S. right there. You know, our Independence Day is the 4th of July, which out there. So we have all the fireworks and everything, and of course, 4th of July is in the middle of the summer in the U.S. So everyone has barbecues and that stuff. I don't know what happens on National Day other than people take the day off. I know there's a parade downtown, which I've never been to, but I suspect with the holiday being on a Wednesday, nobody's going home. Is that a fair assumption? You're stuck here in the hostels during that day? I prefer holidays that are on Tuesdays and Thursdays, to be honest, out there, because then it gives you an excuse to take Monday off or Friday off, and you can convert it into a 4-day weekend and you can go someplace. A Wednesday holiday is almost a complete waste of time out there. You get to sleep in and out there. So, all right, I'm going to jump ahead to chapter 6. I don't think I covered this chapter, have I? I think I covered up through chapter 5. And I was thinking I hadn't covered 5 when I was going through my notes this morning, and it was like, no, I've already covered that there. So, out there, and I've covered some of functions. I have not talked about recursion right there. And recursion is a very interesting topic in C, and you'll see why it's an interesting topic. Here comes some of our gentlemen right there. I was picking on the guys earlier that there, since they're always late, right? They're following Malaysian time. You guys are getting prepared to go to Australia. Australia follows Western time, which means 12:15 means 12:15 typically. That there. And actually, I know in the UK, some of the lecturers will actually lock the door at the start of the lecture. That there, which is kind of. I don't think they do that in Australia. We don't do it in the US either. But I've known lecturers in the UK that will actually at 12:15 they go over and lock the door, and you're not allowed to enter. That there. So it's one of those interesting things. That there, if you look at European mindset on times, go to Japan. You can set your watch by the train schedule. And there, Malaysia is not quite as strict on time. There. Okay, I'm just going to jump into chapter 6. I was just telling the ladies you can pass it on to the gentlemen, and it'll be on the recording. I'm going to set next Thursday, and I'll put something on Facebook as the due time for the midterm project that I assign. I have not shown you how to do that. I will entertain questions on how to do that. Unfortunately, this week we're not going to have computer time, so you'll have to use the lab on your own time, although I keep my lectures to an hour so you can have plenty of time out there. But you're only taking what? How many classes are you taking currently right now? 4 classes? What? 3 classes, most of you? How many other subjects are you taking? How many subjects are you taking right now? 6 subjects? Oh, you got a very busy schedule then. 6 subjects is a very heavy. Of course, in the U.S., that would be considered heavy, except for that would be 18 hours. That would be a very full load. But most students in the U.S. would actually be working part-time while they're going to school. As I understand, none of you have 20-hour-a-week part-time jobs. None of you go to McDonald's after class and sell hamburgers, right? Actually, 80% of the students in the U.S. do have jobs outside the classroom. And here comes the rest of our gentlemen. So, typically in the U.S., you'll find very few people taking 6 subjects at the same time. So, all right, let me just jump ahead. I'll say it one more time for the folks that walked in late. Next Thursday is the due time, is when I expect the midterm project to be turned in, or the assignment I'm most likely going to go into e-learning and put a Dropbox in for you to submit it via e-learning instead of give me paper copies. And you'll have to submit it individually. Obviously, with a group this size, you're working on it together, right? You know, you can't hide the fact I got 40 people working on one project that's the same. You're working in teams of 2 and 3, hopefully not 10 and 12 that there, but 2 to 3 people is really the maximum that should be working on this project together. That there. If you have a group of 4, you know, the problem is you get much more than that, you know, people aren't necessarily learning out there. So, okay. Let me just kind of go through the subject. I'm just going to cheat and just go through the slides today. That there. And there. And here comes the rest of our gentlemen. There. So, actually, this group is much better than my normal BMI or ICOL group that shows up. You know, I've had people show up as I'm finishing the lecture. You know, I normally talk an hour and 15 minutes or an hour typically, and then I've had people show up as I'm winding down. Out there. So, okay, let's start talking about functions. And you've seen a couple of functions already, right there. So we've already introduced what a function is, but we'll get into more common discussions on functions up there. And we'll talk about passing data to and returning results, function calls, the stack. We'll talk briefly about the stack. The stack is pretty much an advanced, but there, in particular, I will talk about random number generators. There will be another assignment, probably as part of your final. But there, I'm really probably not going to give a final exam. I'm going to have a final project that you'll submit up there. Which, looking at Sue Rye, who normally taught this class, that's what she does up there. Final exams in programming courses are really kind of up there. So there'll be a final exam that'll pass out somewhere about 2 weeks before the class ends up there, and it'll have a portion on C, which will be at there, and then there'll be a MATLAB part, because I'll be switching over to MATLAB in the next couple of weeks. So actually, after recursion and functions might be a good time to switch over to MATLAB out there. So it may be after this chapter is complete, but this is a long chapter. So, okay, out there. So this is kind of the list of the subjects. You've got the textbook. You can go through and read this in more detail. And I haven't really talked much about the textbook, but you know, the textbook actually has much better examples than what I'm giving in class that there. And since I'm not giving final exams in this class, that there were exams per se, you don't have to read the textbook like you would a course, say, in network theory or a course in power transmission and try to memorize formulas, because treat the textbook more as a reference book as you're writing your programs to get examples of syntax from that there. So, out there. So we'll talk about there. And again, this is, as I said, this is a very long chapter right there. You know, and I will definitely talk about recursion, and I'll be definitely talking about random number generators. Okay. This is true, this concept of divide and conquer is true of any engineering application that we do. If you're going to design a building, you know, let's say I want to design this building right here from the ground up. And I'm not a construction engineer, although I have a professional engineer's license in the U.S., which allows me to work as a construction engineer. The U.S. has a different view on the engineering license, that an engineer is an engineer and can do multiple, can do interdisciplinary. And actually my master's degree is in interdisciplinary engineering. So I have non-electrical traits, and I was chair of the construction department for a number of years there at my old campus out there. But let's say we're going to build this building, and the reason I went into that sidetrack where I talked about my having some experience with the construction world is that I know enough about it to be dangerous. Don't ask me to design a building, but I can talk the language that there. So if I'm going to build this building, I'm going to hire people to do different things in this building. I'm going to have one department that's going to design the mechanical parts of this building. They're going to worry about things such as where the elevators are going to go, where the wiring is going to go in that there. They're going to worry about how the doors are selected. I'm going to have another department that's going to worry about putting the foundation down. In that particular department, I would expect to have people that understand the soils, understand concrete, understand how you would build a foundation. I would have another department that would select the flooring and decide what tiles to put down and how we would do the floors. Another department, and these departments could be one person, and one person could be doing multiple things. But we tackle each part of the building separately. We don't sit down and we don't design the building from the ground one with one person doing everything out there. That's just too much out there. So we divide it up into sections. And the same thing with our code. We wanted to design our code where things are in relatively small packages. And we have functions that will do one thing that there, and we would call the function from wherever we need it, whether it's a main program or that there. So we are going to use what's called modular programming. And modular programming typically is also referred to as top-down. We design what our program is supposed to do, and then we put down in our pseudocode the major things. And we don't necessarily do everything in our main program. We call functions to do that there. So, for example, one of the things you're doing on your midterm assignment is you're going to zero out all the temporary variables. Well, you can just call a function called zero temp, and then you just zero those out in that function there. So we do a lot of that there, and we're going to talk about this chapter actually gets more into the mechanics of how we do that there. Practice is what we will talk about, is in doing it. And I'm a big believer that the only way you learn a programming language is you just jump there and start writing code. And that's why I'm not writing the midterm for you. I want you to sit down there and just start writing code and fight through it. I didn't get this bald head because I'm old. I got it from two things caused me to pull all my hair out. One is raising two teenage boys. The young gentlemen that there. I don't have any experience raising girls, so that there. I have no daughters and I have no granddaughters. I have 2 sons and 3 grandsons and 1 step granddaughter. That there. So I have no experience in raising girls. That there. Besides, girls would probably manipulate me too much. Girls know how to manipulate fathers and grandfathers, right? Yeah, the girls just smile. You know how it's done, right? That there, you just go to your dad with that cute little baby smile and you show your teeth, and he gives you what you want, right? That there, guys have to go behind their father's back and sneak around. That's why guys are so much sneakier, and you got to watch them. That there, so and believe me, my sons were very good at trying to sneak around. Out there, and then they got surprised when I would sit down and tell them all the stunts that they would pull. Out there, but regardless, getting back to the subject that there, we're going to break our project up into the mechanics of how things are done. There, so again, we're going that the random number generators are important because one of the things we do as engineers is we simulate, and the world is contained with a lot of random parameters. A lot of things happen that are either random or pseudo-random. Now, if you study Islam and you're a believer in Islam, you believe that Allah predestinates all that. But from an engineering standpoint, we have to treat a lot of things as random events right there. So, especially when you get into the electronics world. So we're going to talk about function prototypes. I'm not really going to talk about function overloading. Function overloading basically means that I write a function that can do more than that there, and I can do some other things. The slides will probably talk about it, I'll mention it, but I'm not a big fan of overloading functions there, but although many of the library ones are. Function templates and recursion right there. C++ are typically written by combining new functions that you write in classes that you write. And remember that main is a function. Main is a function. It just happens to be the initial function that is called whenever our program is invoked. whenever I call my program, the operating system, which in this particular case happens to be Windows, it can be iOS, it can be Android, it can be Mac OS, it can be Linux, whatever the operating system, when it loads a new program in, it's going to look for a function called main right there, and that's the function that it's going to run right there. But it's a function. So typically when we write functions, we're going to have to write some of our own functions. We're going to define some classes if we're writing in object-oriented C++. If we're writing in standard C-like, which is what I tend to still do, we don't worry so much about the classes that there. And then we have a pre-packaged list of functions and classes that are available in the standard library right there. And the standard library is very important because the standard library varies quite often with compiler to compiler. It varies with operating system to operating system. So if I'm dealing with, for example, C++, if I want to output something to the console, I use the cout and the streaming function. If I want to do it in C, I would use the printf function. Now, printf for an embedded system is going to do something different than printf does in Visual Studio right there. So, or dev C++ that there. But I still call it the same way into my code that there it looks the same, but what happens under the surface is a function of the compiler and the operating system we're looking at. And the standard library functions are important because they allow us to write standard C or C++ code that can operate on a variety of OSs. Now, OS is operating systems right there. So if I write a C++ program and I'm running it under Windows like we're doing in this class, the code looks identical to the same code that if I write it for my Mac at home. I have a little Mac Mini that I use for testing out there, and the C code looks exactly the same. Now, what happens under the surface is completely different because it's maybe a different processor, it's a different operating system, and the way that it talks to the console is different than it is in Windows. If I'm writing the same program to operate on an Android phone, again, it's going to operate very similar. The code's going to look very similar, but what happens under the surface? So these libraries we call them almost the same no matter what operating system we're using, but what happens under the surface? If I'm designing, for example, a washing machine, I won't use dishwasher because dishwashers aren't common here. If I'm designing a washing machine with a large LCD display, and I I use the streaming cout in order to write to the display, my code is going to look very similar to what it would be on a Windows machine, right there. But what happens under there, because now it's got to talk to the LCD controller and everything else. Functions allow us to modularize that there. Modularize that there is we separate its tasks to smaller, self-contained units that can be tested and on their own, and you make sure that a function works at there. So if I want to write a function to find the roots using the quadratic formula, I can write a function root 1, root 2 equals find roots right there, right there, and we call the function. It runs the quadratic formula and it comes back and tells me whether my roots are 2 real roots, 2 repeated roots, or 2 imaginary roots right there. So I can write a function to find the roots of a quadratic formula. And for those who don't remember the quadratic formula, right there, a quadratic formula is going to be 0 is equal to x squared plus, I'm going to say a, b, x plus c, for example, right there. I don't know if that's standard form. I haven't taught the quadratic formula for a while. And this produces a graph that looks like this right there. And this graph can have 3 possibilities. The roots are when the graph crosses the the y-axis or the x-axis right there, and I can have two real roots. I can have two repeated roots where it crosses, it just touches, or I can have two imaginary roots where it doesn't cross, right there. But it crosses if my roots are complex, right there. So my roots may be are complex numbers, and I could write a function that says that root 1, 2 is equal to, and I can't remember the quadratic formula, but it's got something under the bottom on here, that there. Well, it's 2a under the bottom, and it's not minus b plus minus the square root of, I think it's what, c squared minus 4ac, is that right? Or b squared, something like that. Again, I don't memorize formulas out there, but I know it takes that form right there. And this form right here, if that happens to come out negative, then we got imaginary roots right there. So, but we could write a function that finds the two roots right there. And that's what this whole discussion is talking about. Is that we can write a function there. It turns out there happens to be a function like that already written, at least MATLAB. So, again, the main thing is that we can write this function one time, call it anywhere that we want to in our code, right there. And there can be reused from perhaps different locations in the same program and are hidden from other functions right there. So everything in this particular function is local to that function, that there it doesn't depend on things outside of it. We pass variables to it, and we return back a value. We may not pass a value back. We may not do anything. In other words, we can write a function that just simply clears the screen. We don't pass anything to it. We don't return anything back. Or we can write a function that we don't pass anything to it, that just zeroes out a bunch of variables. Our functions can do multiple things. Now, one of the things to also keep in mind, they don't mention it in the set of slides. It might be on the next slide. I didn't memorize these slides. Is that it's very common for people to write functions that are placed into a library in a corporation, and other people can look at those functions and steal functions that other people have written. So they can also be reused in different programs right there. So it's just one of those things that there. So again, to promote software reusability, every function should be limited to performing a single well-defined task, and the name of the function should express that task. This gets into this whole idea of software reusability. Back when I first started, in industry, we're going back 35 years ago or so. I worked for a company and I was in test engineering, and we wrote a lot of functions in a language called Rocky Mountain Basic. And Rocky Mountain Basic was a version of Basic that Hewlett-Packard developed out there, and what my job was at there is we had these little Hewlett-Packard works, small computers that they didn't run Windows. They ran a version of Unix that Hewlett-Packard put out at that time out there, and they would interface with oscilloscopes, function generators, bed of nails testers out there, but they were interfaced to hardware out there. And we would write programs that would test circuit boards or modules and things like that in Rocky Mountain Basic. Well, it doesn't make sense if you want to say, for example, write a piece of code to turn on an oscilloscope and set all the various parameters for that oscilloscope that they're, every time that I'm going to use that particular brand of oscilloscope. And since we were using Hewlett-Packard, and it's not Algian, I think it's the name of the company there. Their computers were using all Hewlett-Packard scopes, we were using all Hewlett-Packard function generators, and the company standardized, this is the model scope we're going to use. So once we have one subroutine written or one function written to control the scope, everybody in the company used that function to control the scope. So that became a very, very reusable particular function. I didn't have to write that every time I had a project right there. I would just go to the library and pull it out right there. So reusability is very, very important in terms right there. So a function is invoked by a function call, right there. And when the function completes its task, it returns a result, or it may just simply return back. Now what happens with a function call is I'm going through and I'm executing code, and I go clear temp right there, and I put something like that. That's a function call. And what that tells the compiler is that I'm going to exit my code, and I'm going to go into this function called clear temp right there, and I'm going to execute code. When I finish this, I go right back to where I was at right there. Now this function call may end with a return, or it just may end. If you don't put the return in, the compiler will put it in for you right there. Now in this particular case, I'm not passing anything to the function, nor am I returning anything back. Some function calls may be, say, x is equal to square root of y, right there. This is a function call. Now, square root happens to be a standard function in the math library, right there. I pass a variable called y, and I'm going to return a value that I'm going to place in x. So I'm making a standard function call right there. And we can write our own functions that there. This happens to be a standard math function right there. So, right there. So the analogy is the boss or a similar calling function asks a worker to perform a task and report back. Well, we don't worry about that there. But again, the main thing is that the boss doesn't care or need to know how the function operates. We don't know how the computer is going to calculate the square root of a number. We have no idea how it's doing it, nor do we care, right there. So the worker may call other people out there. I was a department chair for a number of years at my old campus out there. My dean will come down to me and tell me that he needs a report on such and such done by next Thursday. He doesn't care how I write the report. He doesn't want to know how I write the report. I go back to my office and I call in a couple faculty members and say, hey, can you write this part for me? Can I write this part? And I delegate it into smaller pieces to people that work for me. Same thing as a function can call other functions right there. So hiding the implementation that there, ideally we have everything we need to do for that particular function within the function right there. So again, this is kind of the boss hierarchical work out there. Here, he tells worker one to do such a thing, and he divides the work into two different departments. The production planner, and I worked at a company that made brake shoes many years ago out there, and the production manager would tell me that I need 600 of this particular part number by next Friday to complete an order. Well, I would go back to my office and I would write up the tickets, and I would assign the manufacturer of those parts to the workers in my department. I would assign the setup man to set up the machine in order to produce the part. I would assign the production worker to make the part. I would assign the finishing person to finish the part, and I would assign the packaging department to package it up for shipment. So I would have multiple people would do various tasks out there. So that's the whole idea of this hierarchy. Okay. Now, this book talks about functions that are members of class. I'm not worried so much about class. That a lot of the functions are global functions. I come from the C world, not the C++ world, so almost all functions I write are global. In the C++ world, you can have functions that are global or functions that are contained within a particular class. Right there. Function prototypes for global functions are placed in header files, or they can be placed at the top of your code, right there. So that can be reused in any program that includes the header files. Now, this typically, if we're going to write functions that are universal, we would want to use them in a header file. That way we can just include, and you've already did that, include math, for example. Those includes don't include, if you look at those include files, they don't contain the functions themselves. All they contain is the prototype of what the function's going to receive and what it's going to pass back. So CMath, that there is a header file that contains the math functions. We had one for string, as we recalled. We also had one for string manipulation right there. So, or counsel manipulation right there. So we're passing around notes here of some type. Must be planning something. So, all right. I used it already. If you call square root with a negative argument, this will generate an error right there. Some functions that there. Now, one of the things we got to be careful with when we run our code is if you call square root and it produces an error. In a more advanced class, we would talk about error handling routines. How will we handle a runtime error? Because that generates a runtime error. Just like a divide by zero generates a runtime error. And we can trap those errors and handle them in our code right there. Or we can let the operating system handle it, which the operating system handles it in a very ugly way. It just simply says runtime error at such and such that there. And the message is going to be so strange because it will point to the runtime error in the C library, and we didn't write that code that there. So it quite often won't even tell us where the error occurred in our code right there. So that there. So that there. Again, this is an interesting thing right there. For industrial strength code, and when I say industrial strength code, that means code that you're going to put out for general public use, right there. Code that you write in your company just to do a simple little task. You don't have to make it industrial strength, because if you got the wrong values and it crashes, well, someone knows that they did something wrong. But if I sell a piece of code for my Android phone to everybody for 2 ringgits, that there, and it generates runtime errors, customers get very unhappy. Right there. So we always want to generate. We always want to check to make sure that we're passing valid arguments that there. So these are some common math functions right there. So ceiling means that it just basically is going to chop off to the smallest integral right there. Now the ceiling right there rounds to the smallest integer that is not less than that there. So this is interesting. The ceiling of 9.2 is going to be the next highest value right there. That's an integer. Now negative 9.8 is going to go to negative 9 because negative 9 is to the right. You have to assume that on a number line it's going to go to the nearest integer to the right on the x-axis. Right there. So cosine is going to that there. Now, a common mistake with young programmers is that x must be in radians, not degrees. Most of the world tends to think in terms of measuring angles in degrees. That there, if I look at something like that there, you're going to say that that's 45 degrees. You're not going to say that that's pi over 4. That there. So, but the computer is going to assume that it's pi over 4. Right there. So if I want the cosine of 45 degrees, I have to pass it pi over 4. So quite often you would write another function, convert to radians right there. The exponential right there is going x to the x power. The absolute value just simply chops off the plus minus sign right there. The floor goes the other way, that there. It goes to the left, that there. The remainder of f mod, the log, these are a lot of the common math that there. The square root is given right there. Power, where we give it the x and the y value. And we just simply could just call these functions. Y is equal to power 3, and that's going to say y is equal to 3 to the third power is what that's going to do. And it's going to calculate that and put that in there. Almost all of your math functions are going to return a value right there. And when it returns a value, that's going to be placed there. So they're going to be on the right-hand side of the equal sign, the assignment. So function definitions, you can have multiple parameters we pass right there. So we can only return one value. But we can pass it 4 or 5, 10, 20. We can pass an array. We haven't talked about arrays yet. So I got to talk about arrays before I end this discussion on C right there. So there must be one argument in the function call for each parameter. Right there. So separate there. So again, here we have a function called maximum right there. We pass it 3 integers that there. We put the constant there so that there's a remains right there and right there. So again, don't worry about that. This right here is the function prototype right there. That's the function prototype. The actual function right there, course name, get course name, and here's where we call the function right there. Right there. So enter the 3 grades. So we're going to enter the 3 grades, 35, 22, 65, and then we're going to maximum grade as we call this function. And where's the function? And here's the function right there. So this is our function right here. Right there. Notice that we got a return at the end, so that when I call maximum grade, that's what gets put into maximum grade. That's what the function is going to return. So we have a return and maximum value. Now maximum value is of type int, right there. So we receive 3 input variables, x, y, and z, right there. And we say if y is greater than, right there, determine if y is greater than maximum value, and we just simply go through our little routine and we set maximum value to x. If y is greater than maximum value, we set y equal to maximum value, and then we check z. If it's greater than maximum value, we set z as maximum value. So this is going to return the highest of the 3 numbers that we pass, x, y, and z. Right there. So this is typically the only thing that you really need to worry about when we look at functions right there. Now, in C, we can, we really don't need to do anything more than that. That's all we need to do. We don't have to put functions inside of a class. In this particular case, you're inside of a class. But I could write functions without using classes and just stick the functions in after the main. The normal way that we write C, in C++, if we're not going to use classes, we normally do at the top of our program, we do our function prototypes. Right there. Then we do any global variable definitions. And I haven't talked about global variables versus local variables. That's part of this discussion of functions. But global variables are things that are known throughout the program, and we don't have to pass in the functions. And if we change them in a function, it changes it everywhere, right there. So a global variable is something that's known to everything. Right there. Now, then we would stick in any, and actually before global variables, I kind of lied to you that there. I'm going to put a line through there. We would put any type definitions. Now, type definitions should be global, right there. And type, we haven't really talked about doing user-defined types, but a user-defined type might be, for example, a complex number. It would have a real and imaginary part right there. So, and we'll talk about that in probably another lecture within the next week or two, right? Type definitions. Then we do our global variables. And the reason we do our type definitions first is that we may have global variables that are of user-defined types. And then somewhere down here, we're going to put main right here. And main is a function. And then we put in all of our user functions. Right there. Now, that's the way we normally would do this with C or C++ if we're not using class. Now, classes are typically defined as type definitions, right there, typically, right there. So, a class is actually a super, type that there. So as we go through and look at that there, so again, right here, all this, now notice that in this particular case, as we look at this program here, this is our program gradebook right here. We define, include that they're using namespace standard, which I always forget to put that in, that there. And we include the .h file right there. The .h file is all of our function prototypes. We don't have to put that in a separate file if we don't want to, right there. We can just put our function prototypes in as I shown right there. And if it's a small program like we're writing this class, don't bother with the .h right there. So in other words, for this midterm assignment, don't worry about a .h file right there. So right there. So just put our function prototypes in at that point. Here we are going to gradebook, string name right there. That's our constructor right there. That means we're going to pass the name of the gradebook. That's going to be passed to that there. We're going to define a variable called maximum grade. That's a local variable right there. This is our constructor, set course name. We call that particular function right there. And again, this is our function for set course name. This is our constructor right there, return course right there. This is, again, another local variable within that function. This is another variable right here where we go input grades right there, and then we store the maximum right there. So again, these are all functions within this class. Now, if we weren't doing a class, we could just split that there. Now, all these right here are declared in that .h file right there. If they're not, if you're going to copy this, you would just simply put those in at the top right there. Here's our function. Now, this is a public function right there. So again, maximum grade enters. This calls this function maximum grade right here. Right there, gradebook display grade report right there. And here's our main program. Now this is where I talked about the divide and conquer. Here I create a new gradebook. Here I display the welcome message. That's within the class right there. That's a function. Here I input the grades. And here I print the report. My main program is only 4 lines long. Right there. It's only 4 lines long. And when I run it, it displays the welcome message right there. First off, it creates that there. Then it displays this welcome message. Then it asks me to input the grades. Now, the input the grades is not done here. It's done right here. Input grades. So you can see when I write this program in pseudocode, at the top level, I only do these things. Create a new grade book, display my welcome message, get the grades, and print the report. I'm only doing 5 things in my main program. Everything else is done in functions that are contained in the class gradebook right there. So gradebook is right here. This is our we're defining our class right there. This is our class definition right there. We have a maximum grade. That's a global variable within the class. When we generate the gradebook, we're going to pass a name to it right there. You see, when I call this here gradebook, I pass the name to it right there. So gradebook, my gradebook is of class gradebook right there. Just like my car is of class car right there. So I'm creating a new grade book, and the name of the grade book is CS 101 C++ Programming. Right there. So this actually creates the new grade book. Now, again, he's calling this, because we have a constructor which sets the name when we create it, we have to pass the name to it. If I don't have this here, then we'll create a grade book with an empty name right there. So display the welcome message, that's a function that right there that says see out stream welcome to grade book 4 new line and get course name. We call the function get course name. Get course name then is another function within my code, and you can see how this starts getting complex because this function right here, when we call gradebook display message, it calls another function called get course name. Now since course name is a variable right there when we is global, we don't have to pass course name to it, and it's going to just simply return course name right there. Now I could just simply not bother with that, except for what this particular one does is it reduces it to 25 characters is what happens in this function right there. So if I pass it this long course name that's 55 characters, it will truncate it at 25 characters. So course name size is less than or equal to 25. We just set the course name equal to whatever name is passed to it. Otherwise, if it's longer than 25, we set course name equal to name substring. We're calling another function. Substring happens to be within the string library. And we say characters 0 to 25 right there. We start at character 0 and we take 25 characters right there. And we also have a name that there's error that we're adding. Sending an error message saying that our name is too long at there. So again, that goes in the error message. We can display that or not display it. It's a choice up there. But course name right there just simply does that, and then string grade book get course name. We just simply return that there. So again, you can see how these functions keep calling each other, and why function calling is very important when we look at C and C++. That there, MATLAB's going to be the same thing. Function calling is the way life works. That there. When I first learned how to program, we didn't do a lot of function calling. Our programs were long, very difficult to debug, very difficult to work with. But once you get used to using functions, you realize the beauty of only writing code that you have to debug that's 10 lines or less. You could take a piece of code that's 150 pages long, but the largest body of code might be 30 lines because you broke it up into smaller and smaller pieces there. And the beauty of that is if you've got errors, you've only got the 30 lines to look at, to debug. So when we start using functions, and if you do it properly, you end up with programs that are 4 or 5 lines long, even though the main routine is only 4 or 5, but the entire program is 2 pages. But again, each function is only, the largest function on this one is actually the truncate one, and that looks like it's maybe 15 lines long. That's the largest function there. But if you look at this entire program, granted it's 16 lines per page there, but we're looking at 1 page, 2 pages, 3 pages, 4 pages, 5 pages right there. We're looking at a lot of pages of code for this particular function, right? That their program there, but the smallest entity is very small right there. So writing this code is not difficult once you figure out how to break it up into pieces. The hard part is breaking it up into pieces and knowing where the pieces should lie. Writing the individual pieces should be easy. And the reason it should be easy is right there. Right there. Goes back to this observation 1. Every function should be limited to performing a single well-defined task. Right there. I take my car to get it washed. Right there. I'm a lazy person. I admit to that. Right there. And I don't wash my own car. And probably half of you folks are, right? Unless you've got a part-time job running a car wash. Right there. But if you've got a car, how many of you go out with a bucket of soap and a garden hose and a hose and wash your car yourself, right? You don't do that. You go someplace and give you hand someone 10 ringgits and you sit down and read a book, or you don't read books. You play with your phone, right there. You get out your phone and you start checking your WhatsApp messages or Facebook, but you let someone else wash your car, right? Well, when I go to a car wash and I have washed the inside and outside, the first person washes the outside. Then they drive the car over to someone else, and another set of people vacuum the inside. One person will take out the carpets and clean them. Another person will pull out the vacuum cleaner and vacuum. And then the next person will take and wipe the dashes and the windows and all that stuff. So you have 3 different operations that go on out there. So I mean, when you wash a car, let's just think about what happens when we wash a car. First thing is you do a soap, right? You soap the car down with soapy water out there. The place I go to, they've got a little hose that's got a soap dispenser built into it, and they just spray the car with soap. Next thing they do is they actually scrub the car. In other words, they take their towels and they wipe all this grime off out there. And as I said, I'm lazy, which means I'm also lazy to go to the car wash, so I only go once every couple of weeks. So the car is pretty grungy when I take it in. So they scrub it. And then they rinse it, right? Right there. And then quite often, depending on the car wash, whether or not it's a lazy car wash or it's a hard working car wash, they may then dry it and polish it a little bit better. So that's all done on wash the inside. Each one of these is a separate function, but they can also be included in wash outside. So my main program might just say wash outside. And wash outside, we'll have 4 function calls right there. Now I'm looking at washing the car. Then once the outside is, then we're going to go to the inside, and the first thing we're going to do is remove car mats right there. And then under remove car mats, we're going to say clean car mats. Right there. Then we're going to say vacuum inside, right there. And then we're going to say polish inside. I don't know what the right word is, polish. But you'll wipe the dash, clean the windows, do all that stuff with the that there. And then replace car mats. Up there. And this is all wash inside. Right there. And then the third step is collect money and return keys. But my main program right there only has 2 steps. Wash the outside, wash the inside. Clean the inside right there. Inside the outside function, I'm going to apply the soap, I'm going to scrub the car, I'm going to rinse the car, and then I'm going to drive the car. There's 4 steps inside that function. So again, here what we're talking about, to clean our car, we've got about 12 steps there, right? But in my main program, I've reduced it to 2. Within the outside, I've reduced it to 4. The inside, I've got about 5 steps right there. So this is all part of the washing car wash right there. So so when we look at how we're going to design our code, we have to think it the same way as we do how do we wash our car. We have to break it up into the individual steps, and we make these individual steps a separate function right there. So, right there. So again, this goes back to where we were at is when we're looking at this right here, my main code is we display the welcome message, we input the grades, and we display, and then we give the the maximum of the 3 grades right there. So it's a very simple main program. But when you go back to how you wash your car, it's a fairly straightforward right there. So again, this just gives examples right there. Commas separate arguments, max are not comma that there. Guarantees are that there. Again, that's just, I'm not going to worry about that. Sometimes when function arguments are expressions that they're, this is kind of an important thing that they're right here. If, for example, I want to call a function right there, and I'm just going to call, say, x, y, z is equal to dummy, and I'm going to pass it 2, 3, square root 5, for example, right there. It's going to evaluate this before it calls dummy, is what this is saying right there. So sometimes the function arguments are expressions such as those are calls to other functions, and the order in which the compiler evaluates the argument could affect the values of one or more of the arguments there. This is a huge issue, is that sometimes different compilers do things differently. And you just have to be aware of that there. I've ran into issues where I've used compilers that were proprietary only for one operating system or one type of computer. We moved the code to a different computer system. Let's say I'm running something on a Linux machine. I want to move it to a Windows machine, the same code. I want to reuse all the code. The Linux compiler does things differently than the Windows compiler. My code quits working right there. And this is all this is saying is know your compiler. Now, if you're writing desktop code, this isn't as important because typically you've only got 1 or 2 that are now. We're using dev C++ because we don't have a legit current copy of Visual Studio right there. But 99% of the world that's writing industrial code for Windows machines is using Visual Studio right there. We're just the oddballs right there. We're the odd ones, and we're an academic unit. We're not trying to write industrial strength code. Our code is not meant to run on 5,000 or 500,000 computers or 5 million computers across the world. It's just for our own use to learn how to program right there. So we don't worry about that right there. But let's say we write something and it works fine with our compiler. We move it to a Visual Studio computer and it doesn't compile correctly or starts doing funny things. It very well could be a difference in compilers. And these kind of problems are beyond the scope of this class to figure out. Because those are the ones that drive professional programmers crazy. And I'll be honest, I work in the embedded world. I mentioned that before, right? The embedded world means that I'm not using Visual Studio. I'm using a compiler called Kyle for the most part. And Kyle is a compiler, C compiler, C++ compiler that writes code for 8051s, ARM processors, and various other processors out there. Well, Kyle happens to be a very expensive industrial out there. I'm thinking it's in the order of about 5,000 USD for one copy, legit copy, right there. I run an academic version that's free because I'm writing very small programs right there, and I'm only using it for. But when I work, projects for industry, we've had to buy the full version, and I've had, and I actually still have a full version of the compiler that I pilfered that there from a company that actually went out of business. So we all kind of pilfered the various software when we shut the shop, and I took the license and the little dongle for the Kyle compiler, so I have a full version of Kyle out there. And, that's what I would use if I was writing something for commercial use that's going to be large. A lot of people that do small startup companies, they use another compiler called
GCC, which is an open source C compiler that writes 8051 code and ARM processing code. And that's a different compiler right there. And they don't always agree with each other on how they process things. So if I take a GCC code and then I recompile it using my Kyle compiler, it may not work properly. I have to thoroughly test everything right there. So, again, beyond the scope of an entry-level class. We're dealing with one compiler, and it's actually pretty compatible with, from what I've seen so far, with Visual Studio. Right there. So again, if you have orders, doubts, that they're separate, do the assignments beforehand before you do the function call. In other words, before I said that X, Y, Z is equal to, and I called it dummy right there, and I passed it X, Y, or no, I think I passed it 2, 3, and the square root of 5 right there. If you have doubts, what he's saying is rewrite this as saying X, Y, Z is equal to dummy 2, 3, and then I'm going to put Z here. And before this, I would say Z is equal to the square root of 5. In other words, ensure that this is done before the function call. Don't rely on the compiler to do that first, then call the function. Right there. So, for this class, don't worry about that there. So, and because he included this, I think that he got caught with it a couple times. It's normally something you don't think about that there. So, multiple parameters that there. You must check to make sure it's the correct number and types right there. The types are in the correct order. Now, in our case, we're passing it 3 grades right there. But if I was to write a function, for example, roots is equal to find roots, quad, right there. I'm passing it to my function right there, and I'm going to pass it A, B, and C. Now, in this particular case, A, B, and C are floating type or real numbers right there. And since our formula we said was R1, R2, and we're going to assume that roots is, by the way, is a structure. We'll talk about that later. But we'll just simply say roots is equal to that. We can return 2 values back to the structure right there. But for right now, all I'm worried about is roots 1 and 2 is equal to, and we said it was what? Minus B plus minus the square root of, what was it, 2AC minus B squared or something like that over 2A. Is that the right formula? I can't remember. Anybody remember the quadratic formula? Is that correct? That there, you shook your head, yes? You agree that that's right? If it's not right, don't worry about it. It's not important. But the order A, B, and C is very important, because if they're not in the right order, then you're going to get the wrong answers right there. So that's the key thing that he's mentioning here, is that they are in the correct order, and they have to be the same type. So when you write your function, that there again, we can go through and we can look at the power function. The power function is x to the y, right? So if I say k is equal to power 3, 4, we're saying that we want 3 to the 4th. If I wrote this as 4, 3, that's going to give me 4 to the 3rd. They're not the same thing. So the order of which you place these arguments is important. Now, the previous example at maximum, it wasn't important right there. If I pass it 5 grades and I want the average, it doesn't matter what the order is right there. But if I'm going to pass, for example, in this class, I'm going to say final grade is equal to calc final, and I'm going to pass it in, not necessarily for this class, assignment 1, assignment 2, midterm, project, assignment 3, and final exam grade right there. If I call that there, and your final grade is going to be equal to, and I'll say on a scale of 0 to 100, is going to be equal to, right there, I'm just going to simply say the formula is final grade is equal to 0.1 times assignment 1 plus 0.1 times assignment 2 plus 0.3 times assignment or a midterm project plus 0.1 times assignment 3 plus 0.6 times final exam. Right there. The order does make a difference, right? Because the final exam is worth 60% of your grade. This is worth 10%. This is worth 10%. This is worth, I said 0.3%. I don't add up, so I'm going to make this 0.2, and this is worth 10%. So I've got right there, and actually that doesn't add up either. So we're going to make, we'll make that one go away. In other words, it's supposed to add up to 1 right there. But again, that's something you need to check with your code. I'm just making these examples up. But the order does make a difference because my 3 assignments are worth a percentage. My midterm project's worth a higher percentage. My final exam is worth a higher percentage right there. So you end up with these various, the weights of each one of those grades is different. So the order in which I put them in makes a difference right there. So, and that's what we're getting into, that there. A function call that returns void means it doesn't return a value. So I never know the correct procedure, whether it's outside and can't understand it, it's quiet or not. Okay, this is about the only classroom that is close enough. The speaker said you really hear it because it's right outside the door there. So most of the classes. Okay. The other thing that has to be important is the types have to match. Now, what this is saying right here is that if the types don't match, the compiler will try to make a match. And that sometimes ends up with some very unpredictable results right there. So going back to our previous example here, gradebook maximum expects to see 3 integers right there. If I pass a floating point number instead of an integer, or if I pass it a char instead of a number, or if I pass it an array instead of a number, what's going to happen? We don't know. Right there. Most compilers will give you a warning at this point. Right there. So be careful that there is that when you call a function that the types match.
The orders and the types have to match right there. Now, exceptions to that will be, for example, the square root function assumes a type float, and if I pass an integer, it will make it a float, and that's perfectly fine. Converting from an integer to float doesn't really cause any problems. Converting from a floating point to an integer, some compilers will truncate, some compilers will round up or down. It's just a matter of which. The standard is to truncate it, but some will actually do a rounding function right there. So, right there. So again, that there. So common that there. Declaring functions of the same type, double X. There's a double X. It's a syntax here. This is in the program header that there is that I have a program, say float X, Y, Z, and I'm going to pass it float X and then float Y. If I do float X, Y right there, that's actually an error. That you can't do it. You have to declare the type and the variable name for each parameter that I'm passing to the function separately. Right there. Don't combine that. Usually you get a syntax error when that happens. So again, my feeling about syntax errors, you get them and you go back and you fix them. As you saw that even as I write code that I don't know syntax, and lately I've been doing a little bit of programming with the in Java for the Raspberry Pi, which is another C-like language that's got different syntax out there. So it's very easy if you program in multiple languages to have problems with syntax. Compilation occurs, function prototypes don't agree, right there. Linker errors can occur later on, right there. So those are that there. Has too many parameters, and maybe that there. If you're passing at 20 parameters, your function's too complex, right there. So smaller pieces that limit the function header to one line if possible. You shouldn't pass more than about 3 or 4 parameters to a function. If you're passing more than that, you need to be writing another function beforehand to combine some of those right there. Returning the control, again, we have 2 ways of doing that. The most common is if you're returning something back, I would do a return and XYZ or whatever, some variable name. And that's going to return that value back. If I don't have a return value, in other words, my function is declared a type void XYZ, and I pass it some stuff. If I have the words void, then I can just put the return, or I can just end the function that there. In other words, just don't put anything there, and it will return back. Does not reach that there reaches the ending bracket or the return statement. Now, the return statement doesn't have to be at the end of the function, and you could have more than one return statement there, and that there. So, for example, I could have a function. And I know I'm going over my hour and 10 minutes or so at there. That I'm losing people here at there. But I could have a function, for example, that say int max right there. I'm going to pass int x and int y, and I'm going to return either x or y depending on whether x is greater than. So my function could be if x is greater than y, return x, else return y, right there, end of function. So here I have 2 return statements right there. If x is greater than y, return x. Otherwise, return y, right there. So here I've got 2 return statements right there. Some people say that that's bad programming. I don't have a problem with that. So, and that the function does return result of statement return expression.
some compilers will issue errors if you don't provide that. So the compiler will give you an error saying, you know, that you must return a value right there. And I think I will stop here since I can tell when we start getting intermingling discussions that I'm losing people right there. And especially when some of you had to tell others to shut up, right? Right there. So I'm going to, you see, there's 214 slides. I'm only on slide, what slide number am I on here? I'm only on slide 33. So as I said, it's a long chapter. So I'm not going to try to go through this whole chapter in one day. So with that said, I will see everyone tomorrow at 8 o'clock in this room. Could I break your necks and say 9 o'clock? That there? Would anybody be upset about it? You don't have another class after this one, right? And you do have a class at 10 o'clock? What's that? This class only? Do you have a class at 10 o'clock? 10:15 is... Yes, you do. All right, then we have to meet at 8 o'clock then, in case I go over, okay? I was going to try to sneak a little bit of an hour extra sleep, but I guess that there. So, all right, so 8 o'clock, this room tomorrow. Right there, so, okay. You know, again,